two matrices. The first one, what's the order of the first one? 3 rows, 2 columns makes 3 by 2. The second one, 3 rows, 4 columns. Okay. Now, we know that we can multiply matrices that are not the same order, but there is something that has to be true. Remember, it must be that the number of columns in the first matrix matches the number of rows in the second matrix. And we know why that is, because of the way we multiply by going across the rows and down the columns. We need the same number of entries in each of those so that when you're multiplying, they match up. In this case, they don't match up, which means you can't multiply. And you would say that this is a mismatch. That's what your calculator is going to tell you if you try to do it. And notice what that means for us. We had a case earlier where we multiplied a matrix times a B matrix, and that was a 2 by 3 times a 3 by 2, and that was okay. Or actually, it was a 3 by 3. That was okay. We got a matrix which was these matched, and so the result matrix was 2 by 3. Okay, but if I flip the order of multiplication, if I make that B times A, now I have a 3 by 3 times a 2 by 3, and these do not match, which means you can't multiply them, which means that A times B does not equal B times A. Right? We don't have commutative property for matrix multiplication.